Good afternoon, and welcome to the Trusted Research Environment session. My name is Abdurrahman Azab. I work for the Nordic Infrastructure Collaboration and for the University of Oslo. And I'm leading a community called the Nordic Sensitive Data Forum. And I was a project manager for a Nordic project called Trygve, Sensitive Data Services in the Nordics. Today we will have this session about a sensitive topic, how to establish trust between trusted research environments. Let's see if this works. Yes. So NeIC is a collaboration mainly between the national providers in developing e-infrastructure projects for supporting research. And this is our topic, the sensitive data. And this is the definition in the GDPR for sensitive data, mainly the data that can be used to uniquely identify a natural person. The processing of this sensitive data needs to be very restricted. And part of the concepts in GDPR, they define something called data controllers or data processors. And these, in brief, are two types. Secure processing environments, those who do the processing, and secure data archives, where the data are kept. And it's very important to establish this trust. When you are in one country with the research institute, secure processing environment, secure data archive, and data provider, and another country have the same environments, how to establish trust between the different parties so that you can exchange data securely and achieve the federation. I would like now to give the mic to our first speaker, Mark from EGI, to set the scene.
Thank you. I'll need your clicker. I'll probably just be able to, I don't know, this clicker does not like me.
No, the next presentation.
Try to keep it pointed. I had the experience that helps. Yeah.
This is the sensitive place over there. This is the right direction.
Did you de-identify it?
Did I what?
De-identify it.
So remember that slide that Abdul Rahman put up just a second ago with the picture with the secure data archive and the secure secure processing environment as two flavors of trusted research environments? Still nothing. Because what I'm going to try to do is map that to EOSC and put some stickers on the EOSC map to give us a feeling for how, where they are and what we're going to need to make that work. Ah, look at that. And I'm going to use the context of the 5 safes. Who here does not know about the 5 safes? Okay, so I'll explain it in a moment, briefly. There we go. Okay, so first we're going to start with EOSC today. And this is the picture that's courtesy of EOSC Future. And some of you have heard me present this information. So this is mostly I want to describe the core versus exchange. The core are some services that allow things to work together, and the exchange is a set of pointers to data and to services and to various resources that are held and operated by the actual research organizations. In other words, not EOSC. It's not held in EOSC. And the pieces are held together through an interoperability framework. So I'm saying that just to sort of set the scene. Tomorrow, we've had some conversation about nodes. We've had some conversation about architecture. So I'm sharing a slide that I shared yesterday in a discussion about the future of the core and federation. So we have the users up at the top. We have a number of federation services. This is actually a subject of a lot of discussion. So I'm not presenting this as a shall we say, a well-defined or firmly set architecture, but this gives you a feeling that there are going to be some common architectural, federation architectural services, and then underneath that, a bunch of different nodes, and we had some conversation about that yesterday. Again, we don't know how this is really going to pan out, but I think one thing is key, and that is that, again, like I mentioned before, the resources, the data, the services, the processing power, the storage infrastructure is outside of EOSC. And it's pointed to and linked to EOSC through one or potentially multiple nodes or various versions of EOSC. So now we're going to ask the question, where can we locate the different components of a secure, trusted research environment that will enable us to process sensitive data? So I changed context. What are the 5 safes? So in 2017, there was an original proposal. This is in the context of national statistical data. It was not health data. It was kind of targeted at census data. How can we work with sensitive data held by national censuses? And for those of you who are old enough, like moi, you'll remember that if you wanted to work with sensitive census data, you had to physically go to a data center, and they'd open up a room, and you could bring in a notepad and a pencil and nothing else, and they'd give you the data to look at, and you could make some calculations and do some stuff. And then when you left, you could take your notepad and your pencil, and that was it. You couldn't take the data. So there's strict control about that, and that's exactly the same process that we started with. So based on this group in 2017, I forget their names, this is not the link that I'm showing there, they proposed the 5 safes. So 5 components for assuring safe handling of sensitive data. So first, there needs to be a project. It has to be a safe project. So it needs to be defined. It needs to be presented as a kind of an abstract of what you're going to do with the data. Part of that abstract is to identify the safe people that will have access to the data and that will work with it. And by safe, it typically means that we know who they are. We have confirmed that they have been trained in the proper handling of the sensitive data. They know what the sensitivities are. They know what they're not allowed to do. They know what they are allowed to do. Safe data. What data will be provided to the project? So let's say, I don't know, you're doing some research project in health, and you say, well, gee, give me everything, and I'll fish around and see if I can find something interesting. You have to define specifically what you want, and there have to be clear rules and regulations about what you can do with it, what is going to be identified, what if it's going to be anonymized, how do you work with it, how will you process it? There needs to be a plan for that. And all that is written into your safe project proposal, and that's embodied in the safe data definition. Now, when you actually get the data and you have the opportunity to work with it, you have to do so in a safe setting. And if we're speaking in an electronic or digital environment, that means there needs to be a secure processing environment. That's the thing that, one of the things that Abdulrahman showed in the picture before, as well as safe data archives. We need to be sure that we're storing it in a place that doesn't inadvertently expose it in some fashion. And then finally, safe outputs, which is to say that having virtually written a bunch of things down on your notepad, and you begin to walk out of the safe setting with that notepad, that notebook, how do we make sure that the data you're taking out is in fact safe, that it does not inadvertently expose some sensitive data that was not planned? So that's what safe outputs means. So I'm going to rearrange this picture a little bit just to put it into a little bit of context. So we define a safe project as I think of it as a governance construct. In other words, this is how we bring the pieces together. As inputs, we have safe people, the researchers or research assistants, and the data that we're going to work with. And this is not just big gobs of data, it's the specific data that we need to accomplish our objective. Within the safe settings, we're going to have infrastructure, and that includes physical hardware, physical storage, physical compute, actual software that you're going to use. What is the stack? How have you certified that physical hardware stack to make sure that it's not vulnerable to side channel attacks or some sort of inadvertent display of sensitive information. So that might mean that you only get to look on a screen at a plot of data. You can't actually download the plot. You have to physically, all you get is a picture, or you have a video monitor where you're allowed to look at the data. So I'm not going to get into those details, but we assume that there's a safe setting where this work is going to be performed. And then finally, you've produced some sort of output. Maybe you have a snapshot of this plot that you can put into your paper, and that's validated by the people who are in charge of the data to make sure that you did not inadvertently display some sort of sensitive data, or it's reviewed by a data access committee to make sure that this is all kosher and according to the rules. So this is what we're trying to accomplish. Now, how do we map these pieces to EOSC? Okay, again, if you have seen some of my earlier presentations, this is the picture we saw before, and I'm trying to sort of map some of these components onto EOSC. So first, safe people. How'd that happen? Does this pointer work? Oh, look. Okay, safe people up here. And I've pasted this on top of the EOSC Federated AAI. And here, the thing we need is probably a stronger assurance level. In other words, we cannot operate with abdulrahman.blah, blah, blah at oslo.no.ac or something, because that gives you access to the Wi-Fi. That's not strong enough to give you access to sensitive data. So there might need to be a connection or a strong assurance that this email address actually is connected to a real person who took the right kind of training, who's been validated to be properly certified to handle the data. So we need something more than that. And in the words that the Federated AAI people might use, it's kind of attributes. In the words that, for example, the data space people talk about is certifications. So credentials and certifications. Then we have safe settings. This is kind of the place where everybody focuses. And I've mapped this onto sort of, there's a little icon for a computer, a rack. That's probably, in the grand scheme of things, that might be the easiest thing to do, because in fact, we'll probably hear from a couple of people, including your organization, who are going to say, we know how to do this. We know how to build a safe, trusted, a secure processing environment that is properly certified, properly tested, and properly validated as being an appropriate place to interact with sensitive data. So that's the safe settings part there. And we might have a couple of them, and I can see these being identified within EOSC as trusted research or secure processing environments as a service that would be onboarded into EOSC somewhere, and once you identify where it is, there'd be some process for you to get access to it, and we'd have to figure out how to properly fulfill all 5 safes, but that's the safe setting part. Safe data. So I've failed to talk about secure data archives, but I'm assuming that if there's sensitive data, that at least at its source, it's being stored in a secured way. So where it is today is probably in a secure, safe, secure data archive. So the question will be, know where the data is, I know where I want it to go, I know who I want to allow to look at it, eventually I want to have a safe output, and this is essentially a flavor of safe data. In other words, we need to declare the kind of data it is, we need to declare the sensitivities. Let's say you have an identified data set that has people's names in it and their sexual preferences and all the sort of sensitive things that we're not supposed to deal with, and then you make a copy of that data that is anonymized and has all this sensitive stuff taken away, which might be just, phenology. Is that the right word? Phenotype. Skin color, hair color, left or right-handed, et cetera. So all that stuff might be presented in an appropriate fashion consistent with the needs of your research project. So there's some things that we can quickly address now. Now, a little bit of challenges. I'd like to introduce a new idea, which is safe passage, which is the way we get the safe data from where it is to the safe setting. So we probably need some sort of appropriate, secure data transfer mechanism that allows us to take a source data set that we have permission to access, to send it to a target secure processing environment, again, to which we have access because we as an instigator have this requirement. So we probably need some sort of data transfer service that assures safe transmission. And then lastly, the safe project. Where is that? And this is kind of a new thing. We really don't have a place for this in EOS. There isn't no place to define where it is, or there's no sort of data type that allows us to identify the safe people who are involved, the safe data that is involved, the secure processing environment that's involved, et cetera. We might be able to twist and bend the existing groups and virtual organizations that are within the federated AI system. We might be able to do something like that. We might be able to take the project concept that has already been introduced into the EOS marketplace, but that's a very soft technical capability, and it's not very robust, so we probably need something new. All right, so what is needed? Yeah, I'm quick. People, data output, safe settings. I think we have that with some tweaks to the existing capabilities in EOS. I think we need to work on safe transmission, and a safe project is probably an entirely new construct for EOS to make this. Now, I make the point, many of these requirements mirror requirements found in data spaces. So if EOS wants to interoperate with data spaces, maybe meeting those same requirements will be necessary. So last slide, I would point you to as some possible inspiration to Gaia X, which has been working very hard on trust frameworks and has introduced a number of interesting concepts for safe projects, safe people. So research activity IDs, maybe we make a subset of data spaces to represent the project. Safe people, we might adopt the verified credentials and verified presentation of W3C to accomplish safe people. We might use attribute-based encryption to properly encapsulate the data and make sure it's only available to the people who are supposed to have it. And I think that's pretty much everything I wanted to talk about. I'm done. Thank you.
Thank you, Mark. Now we will have two presentations, one from SURF and one from Persona Supercomputing Center about implementation for achieving these 5 safes for data access. I'll start with Yorick. Yeah, Martin, yes.
Which one do you start with? I think it's the first.
The harmonization, yes. This.
All right, thanks very much. So I'm presenting on behalf of both SURF and DANS. My name is Wim Hugo. I'm with DANS, and Jörg van Kiermenade here in front is with SURF. And the work we're presenting originated in a project called Odyssey that is establishing a sort of federated data infrastructure for social sciences in the Netherlands. Now, generally speaking, one sees quite often that there are recommendations in respect of licensing, either public domain licenses or CC BY type Creative Commons licenses. But of course, these things are not always applicable because we work with a lot of sensitive data of one kind or another. And we cannot make these data sets available using open licenses, but we have no current real alternative for those licenses. So we find these incongruous situations in some software where people would select an open license and then go and add all kinds of access conditions on top of that license that is not compatible with the license to sort of address the problem that they have. So a lot of what we are doing here is aimed at circumventing these issues. So there's a whole bunch of things to know about licenses, but I'm only going to highlight a few. The first is that a license describes the rights and obligations of the owner or the rights holder of the object. and the extent to which these rights and obligations are transferred to end users. So that's what's contained in the license. And irrespective of the provisions, of which you can see some examples there, permissions, obligations, and duties, and limitations, and so on, irrespective of what those are in a license, there are typically two extremes. You can waive all of those and say it's in the public domain, or you can retain some of them and say, here's a license that sort of transfers some of these provisions to the end user. The other thing to think about is that we often see that, as I said, in repository infrastructures, it's possible to add all kinds of access conditions and restrictions on top of the license, in addition to the license. But we don't think that this is a very good idea, because the data set or the object may not always reside in that infrastructure. It could move for a variety of reasons, and then the access restrictions remain behind. So we would very much like to include all of the conditions and additional restrictions on use into the license in one way or another, so that it can migrate with the data set and is always available irrespective of where that data set is being used. So the problem to solve is that we want, amongst other things, for the conditions to be machine readable, because otherwise these things cannot be processed at scale. Some of the steps in granting access will always be manual, but there's hope at the end of the tunnel, I suppose, in terms of AI-based automation. But nevertheless, one would like to automate this as much as possible to the maximum possible extent. Another typical problem that one runs into is that people specify arbitrary licenses and access conditions all over the place, but they don't necessarily apply across different jurisdictions, and they may not apply where that data is being used. That's one of the great benefits of Creative Commons licenses, of course, is that their legal code has been tested in many jurisdictions, and they are sort of universally applicable, or as universally applicable as can humanly be possible. So that's a very desirable characteristic of concise licenses that have been verified across different jurisdictions. We've talked about the arbitrary conditions that are sometimes added onto inappropriate licenses. And then the other problem that I personally feel quite strongly about, and there may be some disagreement about this, of course, but arbitrary restrictions are contrary to the spirit of open science. If the decision to grant access depends on who you are and where you work and which institution you're associated with, but it is not clear before you request access whether it will be possible to gain access or not, I think that is fundamentally unfair. It must be possible to determine upfront whether you should gain access to that resource if you meet the qualifications for such access. Okay, we did a little bit of investigation. The statistics are a little old, but I don't think it has changed much in terms of the typical licenses in use in the Netherlands. As you can see towards the right-hand side, roughly half of the deposits of data sets in repositories in the Netherlands are open or have some kind of open license. And then roughly about 30% have some kind of requirement to register, but not much more. So one could actually address 80% of the available works out there in registries by just taking automatic care of those two situations. And then there's about 15% or so of these data sets that are closed, and then all kinds of other additional restrictions are sometimes placed on these licenses. Okay. So we've started looking at the requirements placed on us from Open Science and FAIR and compared that to free culture licenses and identified some use cases that we want to cover. They include being able to identify the end user for the purposes of communication, to verify the end use of the data set, so it may harm the interests of the subjects if it's not verified. So we stated very broadly, it's not about personal data only, but also about sensitive data in respect of ecosystems or commercial interests, so on and so forth, because generically they can all be treated the same. and then the edge case that says the data is so sensitive that any leak will have severe adverse consequences on the subjects. So to address, it's worth pointing out that there are some use cases that we don't address, but I'm going to skip over them because in the interest of time. And we developed these sets of principles that we want to include into what I would call no harm provisions. The main intent is to ensure that no harm comes to the subjects of the research that are in these data sets. So we've identified 4 new license provisions to verify identity, to verify the application either before or after the outputs have been created, or in both instances, to process things only in a controlled environment, and then the very extreme case where the process can see the data, but humans that are working with it can only see the results and never see the data. So we've tried to fit that into an extended set of licenses that are modeled on the Creative Commons licenses. So we inherit typically something like a CC BY license, but with a mixture of these additional 4 provisions to take care of the different use cases that we want to address. And it means that many of the instances that we've identified can now be handled at least semi-automatically, if not automatically. Okay, there are some questions and considerations as a last slide that we are aware of, but we haven't really thought about yet. In Europe especially, the idea of copyright of data is not the same as in the rest of the world. There are limitations on what you can claim copyright on, but in practice, most data sets are published with some copyright license anyway. So practice and legislation don't tie up, so one has to think about that. And then there are different approaches to ensuring compliance with access provisions. In some cases, I think Elixir, if I'm correct, has more of a sort of portfolio of typical restrictions and limitations that apply from which you can select to try and determine under which conditions data sets should be available. I may be wrong. I see a puzzled look over there, but I think we're aiming to say that one needs to harmonize the provisions, and then whether you bundle some of them as a license or not isn't really relevant, because that's just a convenient way of ring-fencing the provisions that are applicable to the data set. So it's early days. I think we're looking to look at community support and opportunities to develop these ideas, but any questions, of course, are welcome. Thank you.
Thank you, Wim. We'll take the questions at the end. So this was one of the solutions that is portable based on licensing, and now we will have another solution that is the federated EGA by Salvador Capilla from Personal Supercomputing Center.
Thank you very much. I'm presenting this, or making this presentation on behalf of the Federated EGA group, where we are many people involved, and it's a little bit building on the different concept that has been introduced before. So when we're talking about genomics data, what we want to make sure is that we share sensitive data to enable science, to enable healthcare, but also that those rights are respected. So when we're talking about sensitive data or controlling for access to sensitive data, yeah, better here. So we want to make sure that we control how much the data is exposed under which conditions. That, of course, we need to ensure that individuals, the right of protection of individuals are preserved. We want to comply with the existing regulation, and of course, we want to use data for advanced research, for instance, for doing cancer research. So taking all these aspects in considerations, the European Genome Phenome Archive was created in 2008 at the EBI in Cambridge, and the mission is very simple: permanent archiving and sharing of personally identifiable genetic, phenotypic, and clinical data. As simple and as complicated as that. Then in 2013, the collaboration was expanded, and then the CRG in Barcelona joined the EBI to co-manage the central EGA, what we call nowadays central EGA, and they have been since then driving the development of central EGA. Importantly to say is, this is done in the context of Elixir, the Pan-European Infrastructure for Life Sciences, Data in Life Sciences, and the Global Alliance for Genomics and Health. And this is really important because we want to make sure that what we are developing is not just at European level, and we want to make sure that whatever we do is standardized, and we follow open standard, open source solutions, and so on and so forth. So very much with the previous speaker on open science. So what is the process to manage data specifically? So we have two components here. First, the data that is made available. So then we have whoever is submitting data to the repository. So we need to make sure that that person, that scientist, can share that data, can manage that data, that they have the consent of the patient for that data to be used for research purposes. That means that this person, or the researcher, is signing a data processing agreement, that the institution recognizes that all documentation is in place. Once that is completed and data is deposited at central EGA, then start the part of discovery. I'm a researcher, I want to find a particular data set for my own investigation, so how do I discover that? Through publication, through catalog, through beacons, that is a mechanism to localize data, until the point they say, well, I want to access to that data. So that implies that I need to localize, request access, and to request access, that means first that I need to present a project that needs to be validated by the data access committee, saying, well, there is a scientist, the concept of recognized scientist, and a project that makes sense, so it's not just for fun, it's a credible research project. And once that is verified, then a data access agreement is signed. So again, it's just the researcher, but also the institution guaranteeing that the data is going to be properly used. And finally, data is made available and is downloaded and made visible to that particular researcher. Here is a conceptual representation of how the whole process works, but there are many standards behind the scenes. And we can think, for instance, the visas and passport by the Global Alliance to automatize the whole process of accessing the data. We continue, we're talking about how much data is being managed at EGA. We're talking nowadays about 17 petabytes of data that have led to more than 50,000 publications using EGA data since 2008. So those numbers are quite impressive. The question is, how do we keep growing those numbers? How do we enhance the capabilities? Because every time that there is a new request for more space, for instance, the BSE, who is supporting the Spanish side of EGA, we have trouble, no? Because they say, can you give us 2 more petabytes? I say, guys, what shall we do? Because it's infinite, so all the time they're asking for more. So, well, here you have a quick example of how this data can be used and reused to facilitate further research. What is the importance of doing that? So I'm going to skip that slide because otherwise central room here are going to complain about me. So the whole thing is we want to extend the capabilities of EGA, and that started back in 2018 with the declaration of 1 million European genomes. So there was a political declaration saying, guys, we want to have 1 million of European being sequenced and being used for research purposes across the whole European area. That declaration turns into a project to design and to look for the solutions that nowadays are being implemented through the European Genomics Data Infrastructure. And one of the key enablers is EGA. But it's not just central EGA, it's what we call nowadays federated EGA, where the responsibilities and the capabilities are extended to different countries across Europe. So I'm going to skip this one, just suffering because of the time. So federated EGA was officially launched last year, so basically we're celebrating this month the first year of federated EGA. And federated EGA is a mechanism to enhance the initial capability of these central 2 nodes, counting the collaboration of 5 other nodes, especially the Nordics. We have Sweden, we have Finland, Norway, Germany, and Spain. And the German case is very interesting because they look like a unified node, but reality is they are a federated node itself. So they have 5 different sites across the country. So this allows or give you the flexibility for each country to organize as they desire, or as they can, or as they see fit. So the federated EA is an idea that, well, there is a legal framework to be signed to join the federation where you commit for 4 years at least to maintain the data. Actually, we don't have anyone saying they are abandoning the federation, so we may enter into trouble to comply with our mission, permanently archive data. What happens if a node is leaving? We haven't get to that point, and there are many people who are really interested to join the federation. But it wasn't mean joining the federation. Joining the federation means following this path, and there are a more conceptual path, and there is another one that is more technical. So to join the EGA, the federated EGA network, first, of course, you need to show interest. So, expression of interest saying, guys, we would like to join the federation. We want to present the use case. Sometimes it's a mandate by the central government. Let's say Portugal received the mandate or the Elixir node in Portugal received the mandate by the central government saying, guys, you are going to take care of the genomics data in Portugal. So they need to present the use case. Then they need to make or follow the EGA of federated EGA maturity model self-assessment and present those conclusions to the different committees. That is the conceptual part, and then there is the technical part, where you need to demonstrate the capabilities that you have. That implies setting up the federated EGA node in your own premises, and then run a mockup, meaning unable to receive data, unable to manage the data, including the encryption, the correction, the management of credential, and then are also able to serve the data to the community. So once I have, let's say, demonstrate my technical capabilities, and I have done all the conceptual, admin, and legal paperwork, I'm ready to join the federation. And then until I become a fully recognized federated EGA node. So if we, I was talking before about the maturity model, there is a self-assessment model to understand what means setting up a federated EGA node that cover 6 different aspects, from governance to legal to the technical infrastructure, but also takes on the communication, community building, and engagement. As you can see, there are many different aspects. We have up to 42 different indicators associated to all of the different items here. And we don't require, and that is the reason because it's a maturity model, we don't require to have the highest score. It's not a simple yes or not, but it's a progression for the establishment of the federated EGA. So here, then you have also information about how much different standards, the different aspects that you should consider when establishing a federated EGA node. For instance, Git4EH is an element to facilitate the encryption and decryption and the secure movement of data. So when you were before talking about the safe passage, I was thinking exactly in Git4EH as a potential solution. Just to finalize what is next for federated EGA. So first, to keep building on human data sharing knowledge and experiences, because we have different use cases, we have different setups, and all of them are valuable. We want to accelerate additional nodes joining, not just in Europe, but globally. At some point, we were discussing to remove the E, because that stands for the European Genome Phenome Archive, and look for something else. Continue advocating for community standards. It is essential to guarantee that we can interoperate, that we can work together. And then, of course, support the transnational access to human data across Europe and beyond. So, thank you for the presentation.
Thanks. And these were 2 solutions for the secure data archives. One is portable to your infrastructure, and one is a microservices base that you can deploy as it is, which is the federated EGA. And Salvador presented how to join the federated EGA. Now we will talk about technical solutions for the secure processing environments. So next. So this is one of them, TSD, Tjeneste for Sensitive Data, Services for Sensitive Data at the University of Oslo. It's a secure processing environment. And it's in production since so many years, platform as a service. There are many users, 8 petabytes of sensitive data, and we use web services. So this is the life cycle for any secure processing environment. Start a research project, apply for it, get all of the ethical approvals, get the accounts, collect consents from the data subjects, which is very important. From the patients, you need to collect consents, and they have the right to withdraw the consents, by the way, at any time. And then start analyzing the data, publish the results, share the data with the researchers, and then go on with this until the end of your project. So this is the project life cycle in any secure processing environment. And this is how TSD from inside. This may be familiar to many of you. You need to have a firewall. You need to have a remote desktop access using a gateway for this firewall. Probably need to have an HPC cluster to analyze the data, and a set of virtual machines and services inside with secure storage. Either it is normal storage or block storage. And then on the top of these, you can have some services. Like, for example, the consent need to have a portal to collect the consent. You need to have an interface to upload the data, to download the data, etc. And the platform or the product that we have for allowing sharing or data transfer or collaboration between SPEs is called the TSD API, which is a secure, event-driven, multi-tenant HTTP API. And I will jump to this slide. So this is how it works. So you have the local users with the local IDPs, external users, for example, with the life science AI that can log in also with the external IDP. And there is a collection of services for data import, remote desktop consent. All of them are based on the TSD API. And then you have the proxy, and you have internal identity and access management. And inside the firewall, you can have multiple user tenants. Different research groups can have their own tenant inside the TSD, including the storage, the HTTP resources, and you can have also sensitive data archive. So this is based on OpenID Connect and the tokens, OIDC tokens. So it's also completely compliant with GDPR. And the authorization and authentication process, the ID token insurance for authentication for authenticated users, followed by token exchange. And also the authorization process, it's based on the internal proxies. So the external proxies do the authentication, and the internal proxies do the authorization. This is including the exchange of tokens, the verification of tokens. Some people, they claim that OIDC tokens are not secure. This is not correct. It depends on the way that you exchange tokens and you protect the transfer of tokens. What is very important is that customers can create their own clients. So you can create an app on your mobile that consumes the TSD API if you have the proper token to access a TSD service. These are references for the TSD API, and this is what we want to achieve at the end, for the researchers to access through the API multiple services in multiple countries and be able to get the results and to complete the workflow. And this is one way of implementing it. If we will be able to interconnect the secure processing environments using the TSD API with interoperability between proxies, and having at the top something like Galaxy Portal or the portal of SANE that will be now presented by Wim. Yes, Martin, yes. Okay. So Martin will present another solution for secure processing environment.
Yeah, at Serve. Let's get to my first slide.
No, you will open another one.
Oh, well, oh, sorry. In another session, they were all next to each other, so we could press on. It was also a bit last minute that I was asked to be here, so my presentation was repurposed from another event, so it might not fit perfectly, so I might be a bit, yeah, there it is at least. I changed the first sheet, so the date is correct. Okay. I'm Martin Brandt, I work at SURF as a cloud consultant, and I want to talk about our secure analysis environment project, but I have to give some background about our SURF Research Cloud project to explain the later slides. So this is the reason we started with what our SURF Research Cloud platform/service. We want to have users working together with their data and their applications on a cloud. And there you have a cloud, which means cloud agnostic, data and applications together, and which means we need to deploy something, and users together, which means we need something for federated identity and access management. And we built that in the last few years. And now we have a research cloud where you can easily create reproducible research environments with different types. For example, Galaxy, Jupyter Notebook, Windows, Ubuntu. People can add their own catalog items. Yeah, which are cloud recipes. Yeah, and catalog items which are recipes for cloud environments, and then researchers can log into the platform and start them by themselves, self-service. And we work on the resources. Well, we have our own cloud, but that's not that big. Well, apparently, because everybody wants GPUs at the moment. So we're out of GPUs now and then. But we also have commercial cloud links. So people can choose whether they start their research environment on a commercial cloud or on SURF Cloud. And we work together. We have the SURF Research Access Management Service, which is based on the European ARC project architecture. So you can invite people into projects/collaborative organizations based on their institute identity, and they can log in with their own IDP. And you can give roles inside that collaborative organization. Well, with this very short introduction, I can talk hours about Research Cloud. I think I have enough basis to take those building blocks and explain what we're doing with our secure analysis environment project. Sensitive data. People came to us with sensitive data, and the problem is there are data providers that have data and that are logically scared that it leaks. And that can be commercial data, valuable data, or privacy valuable data. And the goal of the same project is that the data provider cannot say, I cannot share this data because it is a risk. So we need to build something where the data can be shared in a safe way. And the people that asked us for this, you know the different types of sensitive data here. We used an example of 1600 ebooks, for example, from our Dutch Royal Library. The researcher doesn't have the money to buy it, doesn't want to read them all, but does want to do research on them. And indeed, census data, which Mark was talking about. At the moment, you have to log into a computer that's only in a special room and have to connect with VPN to a supercomputer, but the data cannot leave the room. So they came to us. We have users that want to use this sensitive data now. We know the 5 safes, we know everything. So we thought we have our Research Cloud platform, and we're just going to build, bottom up, what we can do. And indeed, part of the 5 safes can indeed be solved. We have seen in our prototype. We have 2 approaches. We have the Tinker environment, where you can tinker with data. not my term, but I like it. So people can run their own software on the actual data. Or we have a blind access, and that means the user doesn't have access, only the algorithm has access. And, oh yeah, there's a line in, from another thing indeed. I will focus on the same project here, so not on the fair data cube, which is another way to work with sensitive data in Server Research Cloud. Sane is a virtual, fully shielded computing environment, and R and Jupyter Notebooks, and this is the goal. And it's from Claria, which is Clarin, Eric connected, and Odyssey, which Wim also talked about, which is more the census data in the Netherlands. And we have a prototype with University of Utrecht, Royal Library, and Sound and Vision Institute, and Commerce, Room of Commerce, and most of it at the moment is not patient data, but data that has copyright or it has value, like books or video or stuff like that. So that's good for a prototype. Well, this is the design we came up with, fairly bottom-up, fairly easy. From the Research Cloud, we can say, create for this collaborative organization a private network that only people of this collaborative organization, which you are invited to with your own RDP, can create a machine in. And there we have a data block. And the data will be in there. And the data owner, we use Cloud Firewall, uses a data owner portal that can be reached. Only the data owner can log in, which is a role in the collaborative organization based on your RDP, based on attributes. And then you can log in and copy data into the data block. After that, you have the Tinker version. And for that project, you invite a researcher based on this RDP, on this identity, and they can start a Tinker workspace. They pay for it, not the data owner, because we can use our platform with our wallets and stuff like that. And they can log in with that through RDP. It's a Windows machine for now, because we knew a bit how to control RDP. We didn't know that as well for Linux desktop environment or for Jupyter Notebook, so we have chosen Windows for now. And our platform starts that machine, and the data owner decides which applications are installed in that machine. So he's in full control of the environment, and the researcher can log in, work with the data, push his results back to the data block, and he cannot copy anything out. And the Tinker machine cannot go to internet during use of the researcher. During the deployment, our platform has both access to the internet and the machine and can install everything.
Yeah, we need to wrap up.
Oh. Yeah, blind workspace is similar, but nobody has access. So, yeah, the data server at the moment is just a Samba machine, but we can work with this. So a data owner can move his data into the data server. We have the internal network that's safe, only federated identity protected, and the researchers can start their Tinker environment and work with the data. And at the moment, the Windows environment is pen tested, and they're very good at pen testing, so we need to fix some small things. And then at the end of the year, real data is getting in there, and people are going to work with it. And I know it's not the most elegant solution, but it works for now that data owners can really share data with researchers. So it's and I think our platform is, can be changed enough that later on we can have nice data collections to data APIs and stuff like that. But for now, it works. Research can go forward. So that's it. Yeah.
Thank you. And now finally with Francesca from Sigma 2, the national provider in Norway, to sum up and to tell you something about the Norwegian efforts.
And maybe talk a bit, right? This is not a presentation, this is an amount of questions. You can move on. I was here talking about sensitive data infrastructure here in the EOSC, and before the EOSC already in 2017, I was talking about sensitive data and secure storage, and I think things has been moving on, but also the world has been moving on. We are not talking about only genomic or sensitive data. Now it's an explosion of data and data methodology, data-driven science, meaning that we are not cherry-picking few data sets. There are methods, artificial intelligence, Internet of Things, that require handling of massive data and collaboration. So this is posing new challenge. So I'm here again to say, okay, this is nice, but we move on. Data sensitivity. We have the tendency to put everything on the same line, but there are several types of solutions depending on what sensitivity you are talking about. But for sure, health personal data is one end, but there are also other ends, like confidentiality, like sensor data from Internet of Things that might capture or not personal information you don't know. So this is posing new type of challenge. Storing and computing, in a way, we are done with it. We know how to build up a secure thing. And we know also to share, or at least there are interesting things, APIs. The things they are doing in Oslo is wonderful, and also I have heard many other solutions for sharing. The EGA is a wonderful solution. And it's in line with my next step, archiving, because data sharing means that you make your data discovery and you share it. And this poses a huge amount of questions that this guy has been tackling in a very pioneer way. Also, the biobank and so on, they are not the only one. So we know already repository, domain-specific repository, biobanks, registering social science database. So what are we talking about? What I am talking about, I'm talking a massive amount of data which might be very scattered, required for modern methodologies such as ChatGPT, Internet of Things, artificial intelligence. This is not cherry-picking a few data sets. This is harvesting a massive data sets that can contain personal information. And in order to do this, you need to have mechanisms to store, annotate, discover, and access. I'm not sure I want to go very much in detail. I'm from Norway. Here we have a few trusted research environments. They were established very long ago. Through a number of activities that are already ongoing, and through the new coming Entrust project, they will try to power up their APIs infrastructure so to become a network. So we are they are prototyping in Norway the networking of these theories. But we have also seeked with the social science databases, which is kind of hosting the research data from social, kind of what we have been hearing from the Netherlands. Same type of data, and they have the knowledge to handle authorization mechanism. And Sigma 2 is the national provider of massive research infrastructure. We have the biggest storage, and we collaborate in the European setting on several activities, mainly non-sensitive. But so here are the players, and here there should be the linking point in order to come to something which is archiving, sharing, cross-border sharing of sensitive and non-sensitive massive data. I drop this and I go to the questions, because I think the there are some questions here that we haven't really tackled yet. We have been talking about trust, but what is one of the most, let's say, important elements to build trust between data controller and data provider, between data consumer and license holder, between whatnot? It's a transparent way to handle the data. So automatization is a way to handle data. Standardization, it helps in, let's say, reduce to zero error-prone human operation and allow massive handling of data. Yeah, well, that's easy to say. We automatize everything, but what? Just a simplified view, to share data, whatever data, you need to make the data discoverable. And in the case of sensitive or protected or business confidentiality data, you need to have some sort of control of the metadata which are published, right? And the license and where they are located. And this one is maybe one of the, so to say, easier thing, although metadata ontologies are not, it's not a trivial thing. But then once the data has been discovered, then you need to access the data. So you need to send a request for this data. And this is what you were showing, which is in EGA is very much still a manual thing. Requires some sort of people looking at this thing. And what I'm questioning is, can we imagine a situation where we automatically send a request, the data controller get a request and check a consent, and the consent is machine readable and is according to an ontology, so that across border, across domain, can be actually translated into yes or no, you can get the data or not? That's a challenge. I don't know how much time we have.
I think we need to
wrap up.
To give a chance to the next presentation or the next workshop. We apologize that we are a bit over time because there were some technical problems. So there are 10 minutes left for the next workshop. So maybe if there are very short questions.
Any question so far?
Before we wrap up?
Yes.
I have one that I also put on Slido. I'm actually coming from an international association on biodiversity information that organizes international conference since the 80s. I must say our participants are, without being pejorative, really geeky. And the biggest fun was every year to have posters that imitate Star Trek Enterprise vessel, to have reference to Lord of the Rings with our data, like volume my precious data and things like that. In the recent year, we had to stop. We cannot do that anymore because we have to sign 10 pages of I will never use an image that is copyrighted. I will never use an image where I don't have the authorization by the owner. I cannot make any joke that would be offended being any people in any language. So we lost all of them.
You know what?
How do you keep the balance?
Exactly.
Fun in our job, these people who brought a lot to the community and still understanding that we need to show some form of respect.
This is why automatization of some of the crucial steps that unfortunately I didn't have time to elaborate a little bit would be valuable for facilitating your work and facilitate not business research. Because in the business, all these questions, they take it very lousy, right? So in this very moment, the commercial business is going way faster. They have the possibility to do things with data that we are not daring to ask because we don't have the mechanism to check that we are doing the right thing.
Thanks. And sorry again for the delay. I'm sure that there are more questions. But to wrap up, we have presented the basics for the 5 safes and the 2 examples of sensitive data archive protocol and then secure processing environment. If you have any further questions, you will find our names on the workshop website as part of the conference. Please contact us for questions, and also we have the community sensitive data forum, sensitive-data@neic.no. Please send questions or join the community. Thank you for attending, and I hope that you learned something today from the session. Thanks.